सर प्रेसिडेंट बनता है तो वो पहले भारत आता है। खैर जो भी है, यहाँ पर आप देख सकते हो कि कई लोगों
as well, and then you could have some background kind of beneath the border. You'll see what I mean in a minute, but I'm kind of just explaining why we have these two images here. Then of course we have the white car. Again, this is just so you guys can have some options when we're using the cars. Off to a good start. That's actually a pretty difficult thing to do, so congratulate yourselves if you made it through that. Now, let's see how we can move the car forward. So we have our self-dot velocity. We have 'The maximum velocity, we have the rotation velocity, we have the angle. The next thing we need is the acceleration, because cars don't just instantly reach their top speed. They take a few seconds to get up to speed. When you slam on the gas, you are accelerating, you're adding more force to the tires, you're going faster, and then eventually you reach kind of like a terminal velocity, which is what we're going to get to here. So I'm going to say self-dot acceleration, did I spell that correctly? Looks like I did, is equal to 0.1. So this means every time that we are pressing down on, I guess it's going to be the W key to go forward, we're going to increase the velocity of our car by 0.1, let's call it pixels per second. That's maybe the unit that we're going at. If you want to accelerate slower, then make this 0.05, right? Or if you want to go faster, make it something like 0.2. Anyways, we have that. Now I want to define a method, and I want to call this move. Underscore forward, okay? So define move forward, and inside of here, I'm going to take self. Now, all this is going to do is it's going to increase the velocity of my car based on the acceleration, and if I'm already at the maximum velocity, it just won't do anything, but it will move me forward. So inside of here, I'm going to say self.vel is equal to, I guess this is going to be the minimum, the minimum of self.vel plus self.acceleration. and self.max underscore velocity. So what this is doing is saying, okay, well, if self.vel is already at the maximum and we add self.acceleration, we don't want to go faster than the maximum. So we put self.maxvel here. So if this is greater than this, we just default to the maximum velocity. If it's not, though, then we will increase the speed of the car by the acceleration. Remember, the velocity starts at 0, okay? So that will increase our velocity. Now, that's great, but we actually want to move the car forward. So to do that, I'm going to make a new method called move. I'm going to say define move like this. And inside of here, after I increase the velocity, I'm going to say self.move.
J1, 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 J1.
Now, the thing is, inside of move, I need to actually calculate what direction I'm going to move my car. Because if I'm angled to the right or I'm angled to the left, then I need to move in that appropriate direction. I can't just go up or go right or go left. So I'm going to start by just showing you how we move in one direction, so I guess one plane or one dimension, and then I will show you how we can move in multiple dimensions. So move X and Y based on the direction of our car, and that's going to involve a little bit of trigonometry. Anyways, inside of here, I am going to say self.x plus equals self.velocity. So we're just going to move to the right based on whatever our velocity is. That's all we're going to do to start right now. Then we'll get more complex. Okay, so now that we've done that, we want to implement another key press to move the car forward.
radical name म्हटल्यानंतर क्यों 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 ओकी ओकी क्या सोचते थे ना ओके ओके परसों ओह नाइस नाइस Gucci Kaguchi Go Gu Gucci Go Enter New Uki no to jest... No. Dai. Dai. Construction. Construction. Code. Yamacha. Sun. Okay. केलं राहून नाही नाही पप्पाला सांगितलं नाही का तू पप्पाला सांगितलं नाही मग येतील ना घरी एवढा वेळ कुठं थांबतील
So I'm going to go here and say if keys pygame.key underscore w, then player card dot if to then we'll get more complex. Okay, so now that we've done that, we want to implement another key press to move the car forward. So I'm going to go here and say if keys pygame.key underscore w, then player card dot move underscore forward like that. So now as we press down the W key, we should increase speed. As soon as we get to the top speed, we'll stay at that speed and we'll move forward. Now remember, we're not decreasing the velocity here. So as soon as we hit the maximum speed, we'll stay at that maximum speed. Even if we let go of the W key, we'll keep going at the same speed. I'll show you how we fix that in a second, but just wanted to note that as we got in here. Okay, so
काहीतरी प्रॉब्लेम झाला इथं.
I've loaded. Now notice when I press W, I move over to the right like that. Now I'm going to stop as soon as I let go of the key, but when I press the key again, I'll be moving at the maximum speed. So that's it. That's how you move one direction, right? We just incremented the X of the car, and that moved our car over. Okay, that's great, but we ideally would like to be able to move in 2 dimensions. So this is where I need to pull out the Paint program and start showing you some trigonometry. Okay, so I'm here in Paint, and I'm going to start describing the trigonometry that we're going to use to actually move in the direction that we're facing. This is not trivial. This is why I'm in Paint. Now, please go easy on me. I am using my mouse, so this is going to be really rough, but it will give you kind of, you know, what you need. It would give you the basic visualization of this. So the idea is, we have some car. Let's say this is our car. Now, if he's just moving this way, all we have to do is move the Y direction, right? If he's facing completely up, then we can just move that direction. If he's facing completely to the right or completely to the left, any of these kind of polar coordinates here, then we can just go in those directions, right? It's very easy. We can just decrement the X, increment the X, decrement the Y, increment the Y. However, what happens if we're moving on an angle like this? Well, it is not so simple now to actually figure out how much we need to move this guy by, because we can't just move by the X and we can't just move by the Y. We need to move by both of them. We need to go some amount up, right? And some amount to the right. Now, first of all, what are those amounts? Well, if you said the amount is equal to whatever the velocity of the car is, that's incorrect. The reason for that is if my car has a heading like this, like it's pointing this direction, then the velocity that we have is in that direction, right? So let's say my velocity is 4. Well, if that's the case, then this is 4. That does not mean that my X is 4 and my Y is 4. In fact, I need to use this total velocity to determine how much X and how much Y I need to go by so that my total velocity accumulates 4. Because when I'm moving in 2 directions, I'm moving, well, 2 ways. And so I need to sum the velocities, but it's not as easy as just adding them together to determine what the total velocity is going to be. Now, in this way, we're going to go in the opposite direction. We're going to say the following. We're going to say, okay, well, this is like a right triangle, right? We want to go some direction X, some direction Y. So let's say X and Y like that. And then this is our total velocity right here. Now, it turns out that we know this angle. And if we know this angle, we can actually figure out what Y and what X are by using trigonometry. So there's a few very popular equations. The way I remember them is the following. We have SOH, which is SOH, and then we have CAH, CAH, like this. So CAH, and then we have TOA as well, TOA. Now, O stands for opposite. Now, this is relative to the angle that you're talking about. So if I'm talking about this angle right here, the opposite side is Y. So OHA, those are all sides, okay? That's side lengths is what I'm talking about. And S stands for sine, C stands for cosine, and T stands for tangent. Anyways, I have my angle. So the opposite side is this because that's kind of what the angle is like facing. It's what it's looking at. And the adjacent side is this. It's X because that's what's beside the angle. That's the way you can think of it. So if I want to solve for Y here, keep in mind I know my angle and I know my velocity, then what I need to do is the following. I need to set up my equation. So I'm going to say that the sine of theta is equal to my opposite over my hypotenuse. Now we know the angle and we know the hypotenuse. So h is really v, which is my velocity. Now let's just plug in 4 because we know the velocity is going to be 4. We'll say the maximum velocity is 4, right? So now we're solving for O. And O is really equal to y, right? Because that's the opposite side. And so what we do is we say that the sine of theta, which we can calculate, we can just take the sine of the angle, multiplied by 4, because we need to take the division and multiply it on this side, is equal to y. So the sine of theta multiplied by our velocity gives us our displacement in y. And then if we go to cosine here, it's just going to be the other way around. We're just going to take the cosine and we're going to multiply that by our velocity, and that is going to give us how much we have for displacement in x. So just basic trigonometry, but I wanted to walk you through that. All right, so hopefully that is a decent enough explanation. What we actually do in the code might differ a tiny bit just because of a few factors, but this is the general idea of how we can solve kind of two components based on one velocity and an angle. We're calculating the x and the y component. That's what they're known as because this is, we can kind of call this a vector, right? Like this line right here. If you know anything about physics, you would call this a vector because we have a angle, so we have a direction and we have a velocity or a magnitude, and then we want to split it into its two components, x and y. Okay, so let's get rid of that and let's implement this. So let's go to our move method, and now rather than moving just by the velocity, we're going to do that kind of fancy equation that we just did. So the first thing I need to do is I need to convert my angle into radians. This is because we use radians in most computer math. Radians is just kind of a special way of calculating angles. In case you're unfamiliar, 360 is equal to 2 pi in radians, and 180 is equal to pi. Okay, you don't really need to know that, but just figured I'd let you know. So we're just going to say math.radians and then self.angle like that. Notice our angle is in degrees because that's how we want to rotate it. But then when we actually are looking for the components, we need it in radians. Now let's calculate the vertical displacement or the vertical velocity. So we're going to say vertical is equal to, and then this is going to be math dot, and I actually think this is going to be cosine for this. Math dot cosine of radians multiplied by self dot velocity. And then we are going to say that the horizontal is equal to math dot sine of radians multiplied by self dot vel. Then I'm going to say self dot y minus equals vertical, and self dot x minus equals horizontal. Now you can switch this to the plus sign and watch what happens, but the reason we need minus is because these are actually going to return to us in a lot of instances negative values, and based on the way that we are angling our car, and just kind of some other things we've done that I don't really want to get into too much. We need to subtract rather than adding. Now, if we're subtracting, that means if this value is positive, we're going to the left, right? And if we are, and we're going up. So we're going to the left and up, which is the way that our angle is directing, so that makes sense. And then if this value is negative, that means that we're going to be going to the right and we're going to be going down. I mean, respective to x and y. Anyways, let's just run our code here and see if this works. And so let's do this. And now notice I can move in whatever direction my car is facing. There you go. So we are now moving our car, which I'm going to call a success. Now, the only thing we need to do here is we need to make it so our car slows down. Because as you saw, let me actually run this again. My car just instantly stops, right? If I let go of the key, it just instantly stops. That's not realistic. Our car is going to have momentum, it's going to be moving, and it's going to take some friction to slow the car down. So we need some way to actually slow the car down when we're not pressing on the key, which is what we're going to do now. So we're going to implement a method here on our car, and we're going to call this reduce underscore speed.
Completed one lap.
Speed. And we're just going to take in self. Now what we're going to do is reduce our speed by half of our acceleration. That is because we can accelerate faster than we can slow down. At least that's the logic that I'm going to use. I'm not sure if that actually applies in the real world, but that's kind of what we're going to do here. Also, just so that we don't slow down super, super quick, because we can accelerate really quick. Anyways, you'll see how this works as I get into this method. Now, I just need to look at where I have this in my other code so that I don't mess this up too bad. Okay, so we have reduce speed. What we're going to do inside of here is say self.vel is equal to the maximum of self.vel minus self.acceleration over 2, and then this is going to be 0. Now the reason we have this is because if this value for some reason is negative, we don't want to be moving backwards, we just want to stop, and so that's why we have the 0 right here. So we change the velocity, and then since we have this move method already set up, we can just say self.move. So now when we reduce the speed, all that's happening is we're reducing the velocity by half of the acceleration, and then we're just going to move. And since this is set up, it'll just work. It's just going to move us slower in whatever direction we're facing, and while we're slowing down, if we're not on the gas, we can still turn, which is a very important thing to keep in mind. Okay, so now we have reduced speed. So what we're going to do is go inside of here, and we're just going to do something. I'm going to say moved is equal to false. And inside of here, I'm going to say moved is equal to true. Now, the point of this is that if we are pressing the W key, we don't want to reduce the speed. But if we let go of the the W key, we do want to reduce the speed. So now I'm going to say if not moved, so if I didn't press forward on the gas, reduce my speed. So I'm just going to say not self, but we'll go with player underscore car, and this will be dot reduce underscore speed. So now you should see that when I'm not pressing on the gas, I'm not pressing on the W key, we should reduce the speed. So let's run this code and let's see what we get. So now notice that we slow down. down, right? And it takes a second to slow down. I'm pressing the key, I let go of the key, and we continue going, and then we slow down until eventually we stop. All right, so with that said, this long video is now over. If you guys had the patience to sit through all of this, give yourself a pat on the back. I did not expect it to be this long, but there is a lot of stuff that goes into moving a car in this fashion. In the next video, we're going to set up the actual collision with the track. We're going to make it so you bounce off of the track. We'll then add a finish line, and we'll make it so that you can hit the finish line and collide with the finish line. So we'll just be doing collision pretty much in the next tutorial. Then after that, we will implement the computer car, so moving around a path, which is also not that easy to do. And then I guess we'll do 4 videos for this series, and in the last video, we'll implement all of the nice stuff like the text, showing the kind of the stats, the level system, all of that fun stuff. So I am back with video 2 in this series. In this video, we're going to be talking about collision and handling pixel perfect collision, actually. Anyways, first thing I want to do is actually make it so our car can move backwards because, well, we didn't do that in the last video and I meant to show that, so let's do that now. So to move backwards is very easy. In fact, it's the exact same as moving forwards, except we just need to modify the velocity and everything a little bit. So we're going to go and make another method here, and this is going to be called move backward. And inside of here, we're going to say self.vel is equal to the maximum of, and this is going to be self.velocity minus self.acceleration. When we move backwards, we need to subtract the acceleration because we're trying to go in the opposite direction. So we want a negative velocity to be moving backwards because it's like the reverse gear in your car. You don't turn around to go backwards. You can just rotate the wheels in the other direction, which is what we're going to do here. And then this needs to be self.maxvel over 2. I don't know why I deleted that. The idea of this is that we want, sorry, this needs to be negative, is that we want the maximum possible negative velocity to be half of the velocity going forward. The reverse gear in your car, you cannot go up to 100 miles per hour, right? You can only go a certain speed. There's a top speed in that. So same thing here. We're going to make it so when you go in reverse, you are going slower than when you are going forward. I don't know why that's super important, but that's what we're doing. So self.velocity minus self.acceleration, and then negative self.max velocity over 2, just splitting that in half. I think that's pretty self-explanatory. Let's now make it so we have a key that does that. So we're just going to copy this, and I'm just going to change this now to key does that. So we're just going to copy this. And I'm just going to change this now to key, this is going to be S. S will go backwards, and then we will change this to be backward like that. Notice I have moved equals true. We need that to make sure we don't reduce our speed as we are going backwards. Perfect. Now that we have that, let's run the code, and let's check if the reverse gear works. True. So it's the minus self.acceleration and then negative self. self.max velocity over 2, just splitting that in half. I think that's pretty self-explanatory. Let's now make it so we have a key that does that. So we're just going to copy this, and I'm just going to change this. Works, and you actually should be turning in the inverse direction, which is correct. And that's why we set up all this stuff, so that it just works when we add other things in the future. Great. So what I want to do is just clean up the code a little bit here. I want to take all of this stuff, so keys, moved, all of the stuff related to moving my player, and I want to make a function here. And I'm going to call this move underscore player. Now inside of here, we will just take the player car. So we'll say player underscore car like that, and then we can perform all of this stuff simply using player car. Okay, so again, just trying to clean this up. So now inside of here, I'm going to say move underscore player, and I'm going to pass my player car, and this will handle all of the movement. Let me just get rid of that. Let's run this. And what I do is I just want to go and grab this reduce speed method here and put this inside of my car class. Reason being that my computer, which is going to inherit from this abstract class. Reason being that my computer, which is going to inherit from this abstract car class as well, does not need to be able to reduce its speed. It's going to be the same speed the whole time, and so it makes sense to have this in the class where it's actually going to be used, because it's not going to be used by anything else that implements the abstract car class. You could leave it in there. There's arguments for both, but I am just going to move it here. Great, so everything will continue to work. We don't need to test that. Moving forward, though, the next thing I want to do is collision. So this is where we need to talk about masks, and we need to talk about how you actually handle collision of different objects in Python. So what I'm going to do is open up Paint here, and we're going to start talking about masks. All right, so I'm inside of Paint here, and I'm going to explain to you masks and how we do pixel perfect collision. So let's start with traditional collision, and then we can explain pixel perfect collision. So let's say we have some object, and let's just make it a circle for simplicity. Now remember I told you that every single surface in Pygame is really a rectangle. So even if this is all that we're showing, we actually have a rectangle around this circle here. So we might not see the rectangle, and the reason we wouldn't see it is because all of these pixels here would be transparent pixels, so they wouldn't show up on the screen, but they're still there. It's still a rectangle. So let's say we have another image, and let's just do it like this, and maybe inside of here, I don't know, we have some green whatever. Okay, this is what this image looks like. Point being is that these two rectangles, the rectangles containing these two images, are overlapping. This is the overlapping area right here. However, if we're looking at these two images, remove the rectangles, they're not colliding with each other, right? The pixels that are present in both of these images are not touching each other. But if we were to use traditional collision, which is just rectangular collision, you just check if two rectangles are lying inside of each other, then it would say that these two objects are colliding. And this is the overlapping area, but again, the pixels in the images are not actually colliding. So how do we fix this? Because I don't want it to show me that two objects are colliding unless the pixels on the screen actually look like they are colliding. This is where we use something known as a mask. Now, what a mask is an array of values representing whether or not a pixel in an image is transparent or present, whether it just exists. It's not a transparent pixel. Now, the point of a mask is that rather than performing rectangular collision like this, we can simply check if pixels that are not transparent are overlapping into rectangular regions. So let's clear all of this, and now let's look at an example of a mask. Let's say we have a very simple image. Okay, I'm going to just go with a rectangle because it's easier here. And we have maybe something like this, okay? We have pixels all in here, pixels all in here, and then inside of the other two regions is transparent, okay? And now we have another image, and let's just do something like this, and maybe we only have pixels inside of this bottom left-hand corner. Well, the mask for these two images would look like this. It's just going to be an array, so we'd have a large array. It's going to be a two-dimensional array, and we would have 1, 0, okay? And again, excuse me, I'm using the mouse here, and then 0, 1, like that. Now for this image, it would be similar, but we're going to have nothing in the first row because we have no non-transparent pixels. And then we would go here, and we would have 0, 1, like that. Okay. Now let's imagine these masks are directly on top of each other. The two objects are completely on top of each other. Then what we would do is we would just compare values in these arrays and see if two 1s are at the same position, right? So we check here. So, okay, there's no 1 here. So we're not colliding in this region. Okay, then we go here. So, okay, there's no 1s there, so we're not colliding there. We go here. Okay, no 1s, we're not colliding. And boom, we find two 1s, which means we're colliding in this region right here. And so we would say, okay, yes, we are colliding because two pixels that are not transparent are touching each other. There you go. Perfect. That's all you need to know. However, it gets a little bit more complicated because we need to know the location of both of these masks before we can do this comparison. In the example I just showed you, we just imagined they were on top of each other. So if I select this and I grab it, it's going to be a bit rough, but we imagine this mask was right on top of the other one. And in that case, it was really easy to check if they were colliding. But what if the mask is sitting somewhere like this, or sitting here, or sitting up here? Well, we need to know that, and that's known as the offset. So we have something, and actually let's make a new file here. We have something known as our calling mask, and then I guess the mask that it's being called on. So let's say that this here is our calling mask, and then this is the mask that this mask is being called on. Well, we need to determine the difference between the top left-hand coordinates so that we can overlap these masks in the appropriate region to determine if pixels are colliding. So I want to calculate the displacement in X and the displacement in Y, so then I know the total displacement of this, all of our vision on this. Look, actually, I will start with traditional collision.
अपन रीड करे কথা articles level easy put it on underline N4 N4 6 Kiken accident Dendo 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 Kishu Boto de Kozo Doro o Hashite iru Iregaimashita. There was a person running on the highway on the electric scooter. Okay. How to pronounce it?
Electric Dendo Kickboard 電動電動キックボード
Dendo kickboard. Okay. Electric kickboard. Electric scooter.
こちらは首都高速道路が SNS で公開した映像です。電動キックボードに乗った人が高速道路に入っていく様子や、路肩から車線に膨らんで走行する様子などが映っています。首都高速道路によりますと、おととい午前3
危険です。Risk. I don't like to risk. 私は危険を過失するのは好きではない。と過失するのはठीक है डेंजरस है क्या शोदो सोकुदोरो शूदो सोकुरो मेट्रोपॉलिटन एक्सेसरी पब्लिक कॉर्पोरेशन शूतो सोकुदोरो नो 会社によると3日の前3時ごろ東京の小道速道で電動キックボードに乗っている人がいました。Okay.
首都高速道路の会社によると、3日の午前3時ごろ、東京の首都高速道路で電動キックボードに乗っている人がいました。
乗っているがいました。この人は、君ぐらい高速道路を走りました。OK。高速道路、トラフィックジャム。高速道路を走りました。 道路の道路トラフィックハイウェイ道路道もたハイウェイなんだ道路は上昇長だアンダルベルケ道路の真ん中ですミドル真ん中を走っているところもビデオに映っています。OK。この高速道路にはハイウェイには強制ですよ今年今までに7歳の電動キックボードが入ってきました。車を運転している人が見つけていたため事故に走らないしませんでした。事故に入らない。
事故にはなりませんでした。
事故にはなりませんでした。OK。No accident。会社は危険なため高速道路には入らないように言っています。そして道があって入ったらすぐ警察に連絡するように言っています。 इजी है। नेक्स्ट ईयर की रायनेन नी गात्सू नी नेत्तो पाई नेत्तो सुपा जो कारा जो जियो जियो कारा तेत्सुदाई सुरू इतोई का दो का ओका अराताना ताकुहाई सेबिसु ओ हप्प्यो शिमाशिता। हप्प्यो म्हणजे सरप्राईज। तेद्दाई 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 ओके तेत्ताई 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 ओके तेत्ताई सुनो इतो
イトーヨーカドー新宅配サービス来年2月から撤退のネットスーパー代替。
इतो या दोका अरातारा ताकू तारानो ताकू हाई सेबिसु पैकेज होम डिलीवरी ओके ओ हाँ चेक करना पड़ेगा। आई हैव टू लीव, बाहर जाना है थोड़ा सा। हाँ मतलब अभी लगेज मैं 10:30 को कल मॉर्निंग